In case you've forgotten from way back in grade 9. Polynomial function is an expression in which all exponents of the variable are whole numbers. What's a whole number? And please don't make me draw the number family thing again. What's a whole number? 1, 2, 3, but also includes? No, that's integers. Naturals are 1 to infinity, 0, high five to you, 0 all the way through to infinity, no decimals, no fractions. So totally making this up, I don't know, x to the 4th minus x squared minus 4x plus 17. That's a polynomial. You did lines in grade 10, you did parabolas last year. This year we're going to focus on cubics, quartics, quintics. Ooh, exciting. So today we're just going to learn how to divide polynomials, which is theory in order to be able to graph, so that's why we're doing it. So a typical question will say divide f of x equals all this stuff by a binomial x minus 1. And so what the question is actually asking is x minus 1 times what gives us the answer. So we talked about this a little bit last unit, but let's go back to grade, I think this might be grade 6. Okay, tell me how you long divide. Where does that 5 come from? 5 times 1. So we multiply, put it underneath. Why 4? What did we do there? So we subtracted. So first we divided 9 by 5. Then we multiplied to get the 5. Then we subtracted. So it was divide, multiply, subtract. Then we're going to bring this down. And then repeat the process all over again. Divide, multiply, subtract. So divide 5 into 42. 8 evenly. 8 times 5. Subtract. Oh, you're just a little fast for me there. Okay, this guy comes down, then we're going to repeat the same thing again, which is divide, multiply, and subtract. So how many times does 5 divide into 24? 4 times 5. Subtract. Repeat the process. Divide, multiply, subtract. So then we could put the decimal and keep going with the zeros. We're not going to decimal it. We're just going to stop there, and we say remainder. So sometimes you'll see remainder 3. Sometimes you'll see remainder 3/5, because that's actually what it represents. It's 3 out of 5. So you'll see either or of those. Same thing. Okay, we're going to do the exact same thing, but now we're going to do it with x's. Are you ready? Chantel's like, no, no. What were the 3 little steps that we did that we just kept repeating over and over and over? Divide, multiply, subtract. You might want to just jot those down in the margin. Divide, multiply, subtract. We repeated those over and over. Divide, multiply, subtract. Divide, multiply, subtract. You're going to put pens down, and you're just going to watch me do the first one, and then I'll repeat it and do it again with you. Okay, so I'll actually just grab paper to do it. Okay, this was like synthetic division that the first time you see it, it's like, whoa. But the more we do, the easier it's going to become, so no freaking out right now. I'm going to do the division first, so I'm going to do x to the 4 divide by x. And some people, visual particularly, need to see it the way you're used to seeing it, because you can't see that. Because we've been doing these questions since grade 9, but that's what we're doing is x to the 4 divide by x. So what do you do with exponents when you're dividing? Subtract. So if I have 4 on the top and 1 on the bottom, what's my division? X to the 3. Okay. Then what I'm going to do is I'm going to multiply, but I'm going to multiply by this whole binomial. And again, what you're used to seeing is x to the 3 times x minus 1. So that's just like a little question from grade 9. So x cubed times x to the 4, and then x cubed times minus 1 minus 3x cubed. Okay, so there's my division, there's my multiply. Now I'm going to subtract. So x to the 4 minus x to the 4, 0, and that's what you want to have happen. I want that to cancel. And now I've got to do negative 2x cubed minus negative 3x cubed. So because I'm subtracting, what's going to happen here? It's going to turn to an add. So negative 2x cubed plus 3x cubed, x cubed. Then I'm going to bring down the next number and repeat the exact same steps. I'm going to divide just the first term. So I'm doing x cubed divide by x. X squared. Then I'm doing x squared times x minus 1. X cubed. Minus x squared. I have no idea. I have no idea. Let's fix that up. Oh my God, I totally forgot about Hunter. Yes, please go get Hunter.
Where was he?
He was supposed to be just sitting outside.
Oh, okay.
Totally forgot about you, Hunter. I'm so sorry. Let me just start that over since I made a mistake anyway and since he wasn't here for it. Sorry, Hunter. You were very patient out there. Okay, so let's pretend that last 5 minutes didn't exist. Let's look at this now. Divide, multiply, subtract. So we're dividing, and again, visual people sometimes need to see it like you're used to seeing it, which is fine. So x to the 4 divide by x. Okay, we're good there. Then I'm going to multiply my x cubed times my x minus 1, and let's do it properly this time. X cubed times x, and then x cubed minus 1. Okay, now I'm going to subtract, so x to the 4 minus x to the 4. And then here's where I got to worry about all the negatives. So this is going to become a positive. So negative 2x cubed plus 1x cubed. Okay, are we good there? Okay, bring the next one down just like before. Then we're going to repeat. First thing I do is divide. So negative 3x cubed divide by x. Negative x squared. Then I'm going to multiply my negative x squared by the outside. Negative x cubed plus x squared. Okay, then I've got to subtract. What's going to happen here with all this stuff here? So negative is positive. So negative x cubed plus x cubed. X squared minus x squared. Okay, and that's okay. That just means I bring down the next two. Repeat the process again. So negative 3x divide by x. Negative 3 times x minus 1. Now I'm going to negative 3x cubed plus 3x cubed. And then 4 minus 3. And I'm out of numbers, so now what do I do? Just becomes a remainder. And again, sometimes they'll put remainder 1. Sometimes a book will put 1 over x minus 1. So just a fraction out of that. Whew, there it is. Let's take a look at some patterns. What do you notice at the beginning of this step, the beginning of this step, and the beginning of this step? It will always cancel. That's what you want to have happen. Okay. If it doesn't cancel, you've done something wrong. This started with an x to the 4. The answer starts with an x to the 3. That will always happen. This will be 1 degree less than what you did here. Okay. Do you see the similarities to what we did here? That's all I want to know at this point is you see the similarities. Okay, let's do it together. If you're a visual person and you want to see it like I did off to the side, just grab a scrap piece of paper. Hello. So step number 1 is the first divide by the first. And again, we're used to seeing it vertically, so if your brain likes that better, then write it vertically. If your brain doesn't need that, then don't write it. So x to the 4 divide by x. X cubed. Okay, and I'm just going to make little notes as we go along on the first one. So this came from x to the 4 divide by x. Then we're multiplying, and because we have a binomial on the outside, I have to multiply both those terms by my x cubed. So x cubed times x to the 4, and x cubed times minus 1. And I'm just going to make a note. This guy came from x cubed times x minus 1. And the last step is subtract, and I like to write the subtraction signs because sometimes when you have the negatives, your brain will see it differently. So I like to write them, and I usually do them in red just so it's obvious. X to the 4 minus x to the 4, cancel. And we want to have that first term cancel or you've done something wrong. And now we're just simplifying. So this negative is going to become positive. So negative 2x cubed plus 1x cubed, negative x cubed. Are we good so far? Okay, drop the next term down just like we did over here way back in grade 6. And now I'm just going to switch colors for the second round. Okay, we go back to division. So negative 3x cubed, or negative x cubed divided by x is. Okay, and just for the first one, that came from negative x cubed divided by x. Now multiply by the binomial, so negative x squared times x minus 1. Distribute it through. Subtract, subtract. Okay, negative x cubed, negative x cubed. Okay, cancel, which is what we want. X squared minus x squared. Cancel. And that's okay if they both cancel. It just means we bring down the next two terms. I'm going to change color for the third step. So repeat negative 3x divided by x, negative 3, and just a reminder for the first one where that came from. And then we multiply the negative 3 by the x minus 1. It's this step people will forget to do the extra negative because it kind of already looks like a subtraction. So I like to do it in red so that we can see it. Negative 3x plus 3x cancels, which is what we want to have happen. And then we have 4 minus 3, 1. So what's the answer to this? It's x cubed minus x squared minus 3, remainder 1. Exactly what you did in grade 6. We just now have x's and exponents and coefficients and double negatives. Again, I know at the beginning you're like, whoa, what's going on? Just like synthetic, the more you do, the easier it's going to become because it's the same steps every time. Okay, together let's write a method. What do you think we should write for step number 1? What's the first thing that we did? Okay, something about division. I heard divide the first, and then it kind of trailed off. Period, end of step 1. Is that enough? So what do we call that out of the polynomial? It's the first term. Okay, what are we dividing it by? Sorry? What do we call that? has a name. What do we call the number that you're dividing into something? So if you're dividing 5 into 80, what's the 5 called? OMG. It's called the divisor. Okay, so if we write down divide the first term of the polynomial by the divisor, is that correct? Is that enough? Do you need more? Oh, okay, so by the first term of the divisor. And if you're not going to remember what a divisor is, then make yourself a note. Okay, so there's division. Okay, something about multiply. By something. So we're definitely multiplying by the divisor. What are we multiplying? Yes, so the answer from step 1, right? So multiply that answer. And I'm going to just add the entire divisor, just so that we're clear we're multiplying both terms. Okay, so there's our divide, there's our multiply. Mm-hmm. Step 3. Okay, something about subtract. Are we subtracting the divisor, though? No, that answer, meaning the one above, obviously, from, bless you, that's it for today. No one else who sits in that desk sneezes, by the way. I've been watching the last couple of days. So now it's not the airflow. I don't know what it is. There's something back there. From something. The thing. We've already actually defined it in one of the steps. From the polynomial is what we call it. And I'm going to grab red and just make a note. Watch for double negatives. It's really easy when your brain already sees a negative there to just subtract, but sometimes you're actually adding. Okie dokie. So divide, multiply, subtract. Keep going. How? I want one little thing before repeat. Drop the next term down. And repeat. Okay, let's do one together this time, and I'm going to go through it fairly slow. So if you already got this, you might think, oh my God, it's so slow, but we're just going to do that for people who are a little bit slower. There's obviously a note here, which is going to be important. So take a look at the polynomial and tell me how this is different from the last one. It's set up differently. Yes. What does that mean? The x cubed is in the back. So what do you think my note is going to say? Yes, the terms must be in order. No, because what we're actually doing is setting up the columns to be the exact same exponents. Otherwise, you're going to end up subtracting, say, an x from an x cubed, and we know we can't do that. So that means the highest exponent all the way down to the constant. I put an extra t in there. Highest exponent down to the constant. Okay, so grab paper if you don't have yet. Division of polynomials is the title. Why am I feeding your paper habit? Yeah, but where's your paper? Yeah. Kind of curious, but not now. Okay, division sign. Polynomial underneath in order, so x to the 4. And then, I think you meant cubed. And then, and then, and at the end. And what goes on the outside? Divide, multiply, subtract. And if you like to see it visually, just have your scrap piece of paper off to the side. So we're dividing the first by the first. So x to the 4 divide by x. A little quiet offer of x cubed. Okay. Then we're multiplying x cubed by the binomial on the outside. So that's just a normal distribution from grade 9. I heard a little quiet x to the 4.
Sorry for the interruption. Any students that are involved in the Remembrance Day preparation, if you could please make your way to the gym right now, please. Thank you.
So if we had not put this in the right order, what would have happened is we would have had a negative 8x squared and trying to combine it with an x cubed. And we know we can't add or subtract if the exponents are different. That's why we need the order correct. Okay, subtract. The first term is never an issue. Everybody knows this one's going to cancel. The problem here is if you don't write that extra negative, your brain's just going to want to combine this. That's why I like to do it in red, and I usually do it really big, just so my brain can see the minus minus. Okay, so the minus minus is going to turn into plus. So I have negative 2x cubed plus 4x cubed. And sometimes visual people need to see that sideways, because it's how we've been combining exponents since grade 8 is sideways. So sometimes do it vertically as a challenge. So when you see it like this, how many x cubes do I have? 2. So I have 2x cubed. Okay, drop the next term and then repeat all those steps again. What am I dividing? So in the next step. So where do I go back to get the division? 2x cubed divide by x. I hear really, really quiet 2x squared. What do I do with that 2x squared? Agree? Subtract. First one cancels, which is what we want to have happen. This mess, again, for some brains just to write it sideways makes it all different because it's what your brain is used to. So this is what I have when I go sideways. What's going to happen in the middle? Positive. And it's going to cancel as well. What happens if two things cancel together? Really common mistake is people are going to put -9. What's the mistake if you put -9? You haven't subtracted, you've added them. That's why I like to write the negatives really clear so your brain's like, oh wait, 8 minus 1, 7. What's the answer? What are we looking for in all this? Remainder 7. And again, sometimes you'll see 7 out of x minus 4, which is fine. It's just a fraction of the divisor. Show me your thumb, and I'm okay if you're still here right now. So if we're in this area, good. Number 3, which also has a note. What do you think my note's going to be about here? What do you think my note's going to be about? So what's different about this question than the other questions? It's not factored, because I got a cubed. This is the division sign. Divisor has a 2. That is different, but doesn't matter for this one, but good thinking. Something different. What are we missing in here? An x squared and the x. So, missing terms, we call them. Must be included. Missing terms must be included with a coefficient of 0. Missing terms must be included with a coefficient of 0. And that's, again, just to keep the placement when you do your division. Otherwise, you're going to subtract an x from an x cubed, for example. Okay, so under the division sign, we're going to start with our 8x cubed. What are we going to write next? What are we going to write next? And what's going to come last? And I'm just going to highlight those because that's what's different in this one. You have to keep the place value, we call it. We always start with whatever's given as the highest, and then anything in between is a missing term. And then the divisor on the outside. So yep, this one has a 2, but that's okay. It's not going to change anything. Same steps every time. Divide, multiply, subtract. Okay, so divide 8x cubed, divide by 2x. Offer 4x squared. Okay, multiply 4x squared by the binomial. Confirm 8x cubed minus 4x squared. Again, don't let your brain trick you here because it's going to want to screw up that 4 because it's already negative. So 8x cubed minus 8x cubed. Yay, cancel. Be careful here because it's really easy to put negative 4x squared down, but what's negative 4x squared? Positive 4x squared. Okay, drop down and repeat. Offer of 2x. Confirm. Okay, multiply. Four x squared minus 4x squared. Woohoo! Again, don't let your brain be fooled because that subtraction was there. It's easy just to put down negative 2x squared, but negative negative is drop down the minus 1. Okay, multiply. Two x minus 2x minus 1 plus 1. What does it mean if we get a 0 down here? Yeah, it means it divided evenly. There's our answer, 2x squared plus 2x plus 1. How we doing? Well, that's the first method, and it's the long method, and nobody uses that method, but the government says you must learn long division, so I showed long division. Everybody else uses synthetic division, which you've already seen because it's 10 times easier. So you have to be able to do both methods. Why? I don't know. Government said so. The other thing I don't understand is why we now teach you synthetic after we already used it last unit. But hey, synthetic division, nothing has changed from last unit. So you, walk me through synthetic division. No. Why is the outside a 2? I think we want the upside down division side. So the first one is? Now what you're doing here really is long division. We just are ignoring the x's because we know when you add that they're not going to change. And the reason we end up adding instead of subtracting is because we've changed the sign here. So it really is long division. It's just a simpler way because we're not dealing with all the x's. Step number 1 is bring this down. Step number 2, multiply and put it in the next column. Add. Multiply and put it in the next column. Add. Multiply and put it into the next column. Add. Always. How does this give us the answer? Well, it's the same way it did last unit. You just didn't know that's what we were doing. Is the answer is always 1 less than the degree of what you divided. So last unit we were dividing x squareds, and that's why we always got an x down here. Here we started with a cubed, so that means our answer starts with an x squared. It's always 1 degree less than what you started with. So we have 1x squared plus 9x. Plus 15. What the heck is the 34? It's just the remainder. That's why the number didn't matter before, because it's just the leftover. Okay, so answer starts 1 degree less than the question or than the polynomial. Sorry, is the last one always going to be? Yes, sometimes it's 0, which means it divides evenly. What's the difference between the constant and the remainder? Well, this is whole number, so this means 2 went in 15 times. This is what's left over. The last word here, the last number here. Oh, polynomial. Isn't that so much easier than long division? Yup. The question would specify. Why? Because the government says so. Mathematicians never do long division. Why would we when this is way less complicated, way less thinking, way less time? But the government says. Okay, method. Solve for Can we have more than just the word coefficients? Ooh, talk to me about the word arrange. I like that. So would they still need to be in order? Do you still need to have the zeros? Okay, so arrange the coefficients of which it just occurred to me, I don't think anyone except me goes through this in grade 9, so in case you didn't know, what does the word polynomial mean? Well, what does poly mean? It's Latin. If you're polyamorous, like sister wives, what does poly mean? Many. It just means many. So monomials, which you started with in grade 9, mono means 1. Binomial, bi means 2. Trinomial means 3. And then above that, we call them polynomials because poly means many. What does nomial mean in Latin? Number. This means many numbers. That's it. So arrange the coefficients of the polynomial and I want to put something about missing terms. So we make sure we have our zeros. Ooh, include any missing terms. I like that. So first thing we do is we drop, multiply, why do we add in this one and we subtract it in the last one? It's because of the first step. So if we were to do long division, we would have a -2, but because we solve for x, we end up with a +2. So we've actually done the subtraction in the first step. We've already accounted for it. Okay, number 5, use synthetic division to divide this polynomial. What would you like to put on the outside? What would you like to put on the inside? Why did the 6 and 11 switch spots? Okay, so watch the order of the exponents.
So according to experience, do we have more questions like this?
50-50. So drop the 1, which is? And what we like about this method, we don't have to worry about negative negatives. We're just adding, so it doesn't matter. What's the answer? Remainder? Why is there no remainder? Because it's 0. Yeah, we just wouldn't do it. Well, then the exam threw this on 2 years ago? Last year, can't remember. And we'd never talked about this, and people were like, ah, what is going on? So read to read, then read to understand. Okay, keywords. There's one more I would do. Yeah, the fact it's a rectangle. And so what is the formula for the volume of a rectangular box way back to Unit 1 in grade 10? Or picture a box. Here's a rectangular box. How do we find the volume? Well, what are the 3 dimensions that make up volume? The length, the height, and the width, or the depth, sometimes they call it. What we're doing is we're multiplying the three dimensions together. So if we have the volume, and we have the height, and we need to find length and width, how do I get rid of the h? So if we have it, it's going to go to this side. So all of this words was a fancy way to say what? Divides. Which as teachers, we're like, oh yeah, no big deal. But as students, when they never saw that and it's provincial exam day and you're in panic, people didn't have a clue how to answer this question. This is just a division question is all they're asking. Any way you want if the question doesn't specify. Oh, you're just a little step ahead of me here. What's going to go on the outside? What's going to go on the inside? Okay, drop and then multiply. This is where it gets all mumbly. -8. Multiply. Why does this have to be 0 for this question? You can't have a remainder when you're building a box. There's no little piece of cardboard sticking out from one of the dimensions, right? That would just be weird. Okay, so how do we find an answer in this? So what that is the length times the width, because that's what we solve for over here when we divide it. The question wants specifically dimensions for the length and the width, so what do we need to do with this? Just factor it. It starts one less than the question, and the question was cubed, so it goes down to squared. You're all factoring experts now. Offer of x minus 1, x plus 8. So possible dimensions, the length might be x minus 1 and the width might be x plus 8. Or the length might be x plus 8 and the width might be x minus 1. That's why it says possible dimensions. Nope, they would accept either or. So we don't know which is the length, which is the width, doesn't matter. This is height times length times width, just regular volume. We can't solve it because we don't know what the volume is equal to, which means we can't find x, so we don't know what x is equal to. Again, from our point